It's a Lucia's time.
Hydrofluoric acid, a poor choice by Walter White. Dissolving the body in hydrofluoric acid would be a slow, complex process. Bone and soft tissue are far more effectively broken down by a strong base, such as molten sodium hydroxide. Molten sodium hydroxide and sodium hydroxide. Hydrofluoric acid is simply hydrogen fluoride dissolved in water.
For making fluorine, we don't want water.
Hydrofluoric acid is a systemic metabolic toxin that acts by displacing calcium in tissue, bones, and sequestering calcium in the bloodstream, causing severe deep tissue necrosis. Your bones become brittle and degraded, what is called osteolysis or skeletal fluorosis. Not authentic medical images. Causes fatal cardiac arrest by binding to calcium in your bloodstream. Splish. So, it should go without saying, fluoride, which is a fluorine atom with an extra electron, has a high Coulombic attraction.
An electrostatic force that entices an opposite charge.
For which the intensity drops off by a square of the distance. The calcium in our body is mostly in the +2 state. Calcium is quite small and polar. The fluoride ion is small
And polar.
meaning that its center can get close to other atoms. These two will get very close and form exceptionally stable and strong ionic bonds, resulting in insoluble calcium fluoride. Thermodynamically, it is a reaction that is driven to completion, effectively pulling free calcium out of biological equilibrium faster than the body can replenish it. Because free calcium ions act as crucial secondary messengers in muscle contraction, nerve signaling, and blood coagulation, a sudden drop in systemic or localized free calcium leads to severe cell necrosis, excruciating pain, muscle spasms, and dangerous cardiac arrhythmias.
Excruciating pain. Hydrogen fluoride consists of hydrogen bonded to fluorine, the most electronegative element.
Treatment for hydrogen fluoride spillages on skin is to apply sacrificial calcium in the form of a calcium gluconate gel. If administered early, it will essentially mop up the fluoride ions. Moving on to some of its other unique abilities. As well as its affinity for calcium, and again, thanks to a high charge and small radius, it can compete with the strong silicon-oxygen bond found in glass by first converting the silicon dioxide to silicon tetrafluoride. This will react with water to give us hydrated silicon dioxide and regenerate some hydrogen fluoride, which will then go on to react with any leftover silicon tetrafluoride, giving us hexafluorosilicic acid. Which is highly soluble, resulting in slow etching, dissolving, if you will, of the glass surface.
Fluorine pulls electron density towards itself, strongly polarizing the molecule. As a result, HF molecules attract one another, forming zigzag chains through hydrogen bonding. These unusually strong hydrogen bonds are why hydrogen fluoride remains liquid at almost room temperature. It boils at just 90 degrees Celsius. So a simple ice bath is enough to keep it condensed. Producing fluorine was far more difficult. Pure hydrogen fluoride is a poor electrical conductor.
Even ultra-pure hydrogen fluoride can self-ionize, but only in trace amounts.
Making electrolysis virtually impossible.
It was then that Henri decided to give up, and nobody ever succeeded to make fluorine. The end.
However, dissolving a small amount of potassium bifluoride introduces enough mobile ions for the liquid to conduct electricity, allowing electrolysis to split hydrogen fluoride into hydrogen gas at the cathode and fluorine gas at the anode. Almost any other impurity is unsuitable because fluorine reacts with nearly everything. With some initial heat applied, fluorine gas is enough to keep a brick burning. Yes, a brick. being made of silicon dioxide, alumina, iron oxide, and other trace minerals, fluorine rips away electrons, exothermically displacing all of the oxygen to create stable fluorides. The greatest challenge wasn't the chemistry, it was the materials. Today, our Roman chemist is visiting Moissan, the first person to isolate elemental fluorine. Moissan contained the electrolyte in a platinum U-tube, not U-cube, a U-tube, later upgraded to platinum iridium alloy. The electrodes were also platinum iridium. He carved the stoppers from fluorite and sealed them with shellac to keep the apparatus airtight.
Respiratory failure and skeletal fluorosis, shortened lives for each who got too close to the dragon. Isolate the elements and got the one to finally isolate the world. What's Henry Moissan? Atomic fluorine gas which dissolves from the surface. The dragon bubbles out of solution. Paris, where many a fluorine martyr lie through blindness, respiratory failure, and skeletal fluorosis, shortened lives for each who got too close to the dragon. Yet none could isolate the element of death, the one to finally isolate it in Paris was Henry Moissan by fluoride, dosed electrolyte via platinum iridium. Fluoride absorption. Fluorine moves across the anode surface lattice until adjacent sides combine to form diatomic fluorine gas, which dissolves from the surface. The dragon bubbles out of solution.
Mon Dieu, sacré bleu. Depuis la guerre, les spontanéistes opèrent, diplomates opèrent, then I imagine a technique.
Yes. Element number 9.
Who said that? The door was cleared. How do you get here?
Congratulations, Monsieur Moissan. You have just confirmed the existence of the most electronegative element in the periodic table.
Le tableau périodique. Laboratoire Lefebvre. You've come to steal my invention. Who are you?
Lucius, a chemist.
Who?
Can you imagine?
Who are you?
Lucius, a chemist.
Who? Sacré bleu.
Chemist.
Who? Sacré bleu. Who are you?
Lucius.
From the philosopher's sandpit,
Imagine.
boiling the meter cube.
town is alive, wealthy, and completely oblivious to
Mountain Looney.
It's a Lucia's time.